In this video, I'm going to look at naming 2D shapes and just explaining some of the properties of them. So the first one we've got up here is just a square. And that, as you see, has four sides that are all the exact same length. The sides, so I could mark them like this just to say they're all the same length. The sides, the opposite sides are parallel. The angles are all 90-degree angles, adding up to a total of 360. And if we're looking at lines of symmetry, it's got a line of symmetry down the middle here. It's got another one across the middle here. It's also got a couple of diagonal ones across here and across here. And rotational, well, it's got quarter turn rotational symmetry, so you could turn it around 90 degrees and it would fit exactly back on itself. When I said about diagonals, when we're talking about 2D shapes, a diagonal is just a line that goes from one corner or vertex to another corner, but not along one of the edges. So a square's got two diagonals here, both which are lines of symmetry. Moving on to the rectangle, again it's got four sides, again it's got 90-degree angles. Again, the sides opposite each other are parallel. This time, these two sides are the same length, and these two sides, the opposite sides, are the same length, but they're not the same length as each other. And again, it has got a line of symmetry here, and another one going across here. But this time, it's got two diagonals, but they are not lines of symmetry. If you try to fold it or reflect it across here, this corner would end up out here, so they're not lines of symmetry. It's just got the two lines of symmetry. And because of this also, we'd have to turn it 180 degrees until it went back on top of itself exactly, so it's just got half turn rotational symmetry. The next shape we're going to look at is a triangle. I'll just briefly mention that because I'll go into more detail in other videos, but it's got three sides, all straight sides, and three angles. They're all going to add up to 180. And I'll just put the names on these as well, just for the spelling. Rectangle and triangle. Now the circle, I've got another video about naming the parts of that and finding the circumference, finding the area. But for now, I'll just say it's a 2D shape. It's got just the edge going right round it that we call the circumference, and every point on that's the same distance from the centre of the circle. And as I said, I've got another video about finding the area of a circle. The difference between the circle and these other shapes is the circle's not got a straight edge, it's not got a side, it's just a straight edge, so it's got no corners either. Then going over the page, going to look at a few more. This one here we call a rhombus, and I'll spell that, that's R-H-O-M-B-U-S. And in this one, all four lines are the same length. All four sides are the same length, just like a square. It's got four sides like a square, but the difference is here, the angles aren't the same. It's as if it's been a wee bit squashed in one direction. So this angle is the same as this one. And also this angle is the same as this one. But these two and these two aren't the same. Just the angles opposite are the same. And that means they're not all going to be 90 degrees, although they will still add up to 360. Now, in this, again, these ones are going to be parallel, and these ones will be parallel, just like a rectangle and square. It's going to have 180 degrees rotational symmetry, like half turn rotational symmetry, just like the rectangle, and its lines of symmetry, there's just going to be two again. going across the diagonals. Then next we come to the parallelogram, and I'll write that out because that's one that some people wonder about how you spell it. But just like parallel, then ogram. In this shape, the opposite sides are parallel. And it's got 4 sides, 4 angles, they all add up to 360. These ones are the same length, and these two are the same length, but unlike the rhombus where they're all the same length, here they're just the same length as the ones opposite them. So with the parallelogram, it's not got any lines of symmetry. There's no way we can draw a line that will reflect exactly, but it has got half-turn rotational symmetry. If you spun it around 180 degrees, it would end up landing on itself exactly, and the opposite angles are equal. So this one and this one are equal, and this one and this one are equal. It's got 2 diagonals, but they're not lines of symmetry. Moving on, we've got the kite here. Now, the kite gets its name from the kind of kite you fly, which in turn gets its name from the bird, the kite. It's got 2 lines here that are the same length, and 2 here that are the same length. But unlike the rectangle or parallelogram, here it's the ones that meet the lines that are the same length meet each other at one of the corners, and these two meet here. So here, these opposite angles are equal, but this angle and this angle aren't equal. And it's only got 1 line of symmetry, just down the middle there. And it's got 2 diagonals, one which is along this line of symmetry, but the other that isn't. So that's our kite. Now we could also look at a shape like this, and also it's got a line of symmetry down the middle. It's got these 2 angles being equal, but this angle and this angle not being equal. It's got this side the same as this, and this the same length as this. So that means this also is a kite, but it's a kind of kite where this corner, instead of being up here above that line there, it's just down here. That gets called sometimes a V kite, but it's got a lot of the same properties of this kite. Another thing I should have mentioned, a rhombus, you sometimes hear folk referring to that as a diamond, but in maths we're going to call it a rhombus. For one thing, if you actually look at a diamond, they don't normally have this shape. They'll be 3D and kind of all sorts of shapes. And secondly, it can just cause a bit of confusion. So if we're talking about a shape in maths where all sides are the same length, but it's not got right angles, we're just going to call it a rhombus. Now, I've got other videos that explain how we can work out the areas of these shapes, so if you're interested in that, you can check out those videos, but I'm just going to leave this one here just now.